Hi, so finally got around to digging into my big pile of teardown items. These are a couple of iris scanners. These are for like security applications, identification, access control type things. These were separate eBay listings quite a long time ago, very, very cheap. I think something like £5 and £25 respectively. Obviously a tiny fraction of what they would have originally cost. They just both coincidentally came up from different sellers. I thought it might be interesting to have a look and compare how sort of two different products approach basically the same problem. I found a few odd little bits of information on the net. The Panasonic one, to set this up you need to sort of connect it up to some PC software, and you like enroll it by sort of giving it the sample person to look at, and it can then add it to its own database, but it can also send that across to a central server. So if you've got, obviously a lot of the time you might have several of these, and it can copy that iris data to all the different units. But the data is actually held locally because obviously it wants to be able to do a fairly quick recognition, so it doesn't have to wait to talk to the server to get the recognition data. The Panasonic has got some fairly obvious sort of anti-tamper things. There's a sort of switch on the back here, and looking at the documentation, if that switch on the back is sort of detected open for any length of time, it actually erases the iris data and also erases the setup data. So I think the idea behind that is you can't sort of steal one of these off the wall, somehow get the data out of it and use that to perhaps sort of fake data to gain entry by producing some sort of fake iris based on the data in it. Obviously these are designed for like quite high security type environments. Software that runs this, it's one of these sort of not horrible license things. The number of people you can have on the system, you have to pay depending on the number of users, so they charge on a sort of per user basis. Both of these have some features in common. They've sort of got this mirror in the front, so the idea is you look at the mirror, and that's where it guarantees that you're looking at roughly the right angle. They've got adjustable angles, obviously for different people's heights. Again, this has got an adjustable height there, and there's two cameras. This Panasonic has also got a simple composite video camera, so you can hook that up to a CCTV system to show the actual, so it can capture a record of the actual person that's entered. So, for example, you can tell if someone's maybe holding up a picture of someone to try and defeat the system. And they both use infrared cameras, so they've got infrared illuminators and an infrared filter on the camera, so they're fairly immune to different lighting conditions. I just powered up this Panasonic unit, and it does actually do a few things. It's still got some sort of proximity sensing, because as you sort of get close, it tells you to look at the mirror. You can also see the infrared LEDs illuminating, but the LEDs don't come on initially, so I don't know if they're running the LEDs at a lower power or there's a separate sensor that's actually detecting proximity. And there's also these sort of guide lights that showed you whether you're too high, too low, whatever.
Please look into the mirror. Please move back a little. Please move a little closer. Sorry, you were not identified.
One thing that's noticeable when it's trying to do vision, it's flashing the infrared illuminators alternately. I'm guessing there could be a number of reasons for that. One could be just to limit the peak power consumption. The other could be it's just taking alternate images from the camera and using the same processors to process both of them. But might get some clues to that when we start looking internally, or it may just be so that it's got a more sort of precise illumination for each eye separately. I don't know. Take the front of this. This is the video camera. I think this may be just completely independent and not actually used by it. There's a BNC output here, so I wouldn't be surprised if that just goes straight to the camera and that's just a completely standalone thing. There's various terminals. You've got power in 12 volts and various information. There's an interface to a card reader, so you could use it as in combination of some ID card plus iris recognition. There's various outputs like recognition output, alarm outputs, and there's down here there's a RJ45, which is probably Ethernet. There's also a mini DIN. That might be perhaps some sort of local programming interface or something. And there's another second tamper switch here, so when you take this cover off, it opens this tamper switch. And if you look carefully, you can just about see this infrared LED at the top. It's just barely visible to the eye, so that's obviously the proximity sensor that's detecting the presence before it turns on the main IR illuminators. And the main illuminators, again, they're just about visible to the eye, so they're fairly near infrared. I did try sort of plugging into this Ethernet port. I could ping it, but I couldn't do anything else. Alright, so let's see what's inside this thing. Right, so there's a wall mount plate to make fixing it to the wall easy. A drawing showing the overall system setup, which seems a little bit pointless to actually put on the unit. Quite a lot in here. There's Altera Apex FPGA, flex cable from the camera assembly. So this the top assembly is the part that swivels, so this flexes as that top flexes. Power board down here. Yeah, so this is clearly a power supply board. The reason for these big caps, it will run on AC or DC, so it's obviously just rectifying it and then smoothing it so it gets a DC output. Nothing particularly exciting on that. Another great big Samsung ARM processor. So that's the back of the secondary vision camera. And that's the cable that goes down to these two tamper detect switches. These do look slightly elaborate. They look like they're using opto switches in there. Yeah, just two slotted opto switches. Seems a sort of slightly elaborate arrangement, but does the job. Just the speaker in there. This is a sort of cast, quite complicated cast casing. Sort of feels very solid. Little OK tick by someone. It's just the sort of front connector board, flex cable to the main PCB. There's that connection's for like a local PC connection for setup. Got a speaker. There's a little front adjustable pot there for the volume for the tamper alarm. Alright, that pot there is adjustable from the side. I'm guessing that's probably for the speaker volume. So that's the little front CCTV camera, just a standard sort of board camera. So just an analog camera module. So this is the camera head unit, so this will have the cameras and the illuminators and proximity sensor. Had these little friction damper things, so this thing sort of moves up and down sort of quite smoothly. So we've got looks like a single flat moulded plastic lens assembly. That looks like one of those sharp proximity sensor modules, and the panel is just a few LEDs behind it to show sort of the arrow showing forwards, backwards, and then there's these LEDs that shine through that give the just show the sort of reject, accepts, and this will be an infrared pass filter. So you've got the shielded flex cable going to the main board. Two separate little camera modules. A few Sony chips there. Not a huge amount on here. I'm guessing most of this data I'd expect to be going straight back to the main board. Looks like there's some stuff on the other side of that board though. A few more oddments on the back. Take a look at that in a minute. The image sensors. And the lens assembly. The two illumination modules. This sharp thing, what was this? Oh, I think that goes to the LED assembly. So that's the proximity sensor. This is a standard sharp 2i02. These are basically triangulation based distance sensors. They're actually quite neat for sort of mid-range distance sensing. They just give an analog output based on a sort of very simple triangulation system. So they've got this weird, funky, sharp custom chip. I think it's a very small infrared illuminator, produces a very narrow beam, and then there's like a linear sensor, so it detects where that beam falls on the sensor. But it's a rather funky little optical package. And all of these front pieces are castings, so sort of very solidly made. Obviously on a sort of nice robust optical alignment and everything. This is one of the illuminator modules. We've got a sort of moulded front lens assembly, then just a bunch of infrared LEDs, just some transistors and resistors there, so it's very just a simple constant current circuit. And these camera lens assemblies, it's probably an infrared pass filter in there. The lens quite a long way away from the camera sensor there. Just falls out. Yeah, so we've got that's an infrared pass filter. Now on the back of this Oki speech chip there's this flash, which I'm guessing contains all the the speech data. So I thought it might be interesting to see what happens if we just try glitching the pins while it's trying to speak.
Please move a little closer. Please move a little closer. Please look into the mirror. Please move back a little. Please look into the mirror. Please look and present your card.
Right, let's take a look at all these boards. This is a power supply board, nothing particularly exciting, some input filtering. One thing that it is isolated, sort of fully isolated supply. That's not too surprising because obviously security systems like this might be running down very long cables over a building coming from all different power supplies, so you really don't want to have any ground loops. Terminal board, nothing at all interesting on here, just sort of the terminals for the connections. Transorbs for protection against sort of spikes and noise, a few unpopulated parts there. Now the image sensors, now quite surprising, these are actually sort of analog CCDs. I wonder if maybe this design sort of slightly predates the sort of CMOS sensors with onboard processing. On this board there's a few sort of Sony, these would be the standard like Sony CCD driver chipsets. There's a bit of power stuff there. So it looks like these are actually analog, output analog video. And down on here there's a Philips chip, which I'm assuming is going to be an A to D converter to turn that video, to digitize that video. And that will also probably explain why we saw the two infrared illuminators going alternately. So it's obviously combining those into probably a single channel stream, so it's digitizing them alternately, just with like an analog switch to switch between the channels. Right, let's look at this main board. This CPU is a Samsung, it's an ARM 920, 150 megahertz, so yeah, fairly low power by sort of today's standards, but obviously fairly sort of high power in its day. Couldn't quite find the exact part number on that, but I'm pretty sure that's going to be the analog video digitizer. That's the memory for the Oki speech synthesizer on the other side. That's actually an OTP problem, 16 megabit with all the speech data, and I'm sure that probably contains data for multiple languages, because when I was messing around with the pins I did hear what sounded like Japanese on occasions. Now I'm not quite sure what this one is. This is an NEL. It's an NEL NLC 0268. I couldn't find any information on this, but the way it's wired seems to be a bit weird. Now, it is next to the Ethernet connection, but that's the Ethernet controller. That does appear to have an onboard PHY, so I don't think it's to do with the Ethernet. I can't see any tracks. Unfortunately, this is PCB. They've put planes on the outside, so most of the tracks are on the inner layers, which makes it quite hard to see what's connected to what. But the odd thing is that almost all the pins just seem to be connected to these resistor networks that just go to one or two nodes, so not really sure what that is. I suppose it's conceivable it might be perhaps some sort of security processor or something with a sort of serial interface. And just a few odd bits of just random sort of logic there. There's a RS-232 transceiver there, which is for that diagnostic port on the front. Not much else on this side. There's a few unpopulated pins. I've looked around for serial debug output and I couldn't find anything. There's one of these I'm sure will be JTAG. The other will be just probably some sort of general spare I/O. And on this side we've got there's two flash chips there, which can have the main code for the ARM processor. There's an Ethernet controller here, the Oki speech synthesizer, LM386 audio amplifier for the speech, a few bits of general glue logic, and this Altera. This is in its day quite a big FPGA. Obviously that's probably going to be handling a lot of the image processing stuff. So it's an unpopulated BGA footprint there, maybe for a RAM or something for the FPGA, or possibly for configuration memory for the FPGA. Now, this lid was actually sort of quite loose on there, so it actually came off. And you see this is an enormous die. This must have been seriously expensive. This is about 16 by 14 millimeters. So it's a huge piece of silicon, and this is a EP20K400 EF. Date codes on these are like early 2000s mostly, sort of 2002, 2003. Okay, a few minutes on Twitter later, it reveals that this is actually a DES encryption processor, 'cause it encrypts the data that it sends over the network. This would have been before the days that sort of stuff would be on board the processor, and they probably maybe didn't have the space, or it was too expensive to do it on the FPGA, or they just wanted an off-the-shelf proven solution. Okay, that's the Panasonic one done. Let's take a look at this. This is an iLock iSwipe Nano. I think it's possibly a slightly more recent unit. Just a wall mount bracket. I've already taken this partly apart. Stuck it back together briefly to show how it all goes together. So the whole unit is on this sort of hinging bracket. It's a much smaller unit, and there's just one connection. That's Ethernet, which is pretty sure it's PoE. The rating on here says supply 56 volts, 0.6 amps. There's a couple of fans in the side, and so it's a much smaller unit than the Panasonic. At the front off, there's a couple of light guides that guide the light up to these indicators, and again this is I think a LED that lights up to show you, to move left right to align yourself. Two big infrared illuminators, two cameras. They've got these rubber sleeves here which are presumably to stop light leakage. So obviously if you've got this massive illuminator, what you don't want is the light bouncing off the inside face of the front panel back into the camera. So these, I think, rubber sleeves just sort of press up against here so that you're not getting any internal reflections. We take those illuminators out, we can see the main board. So we've got the camera modules. Looks like there's a couple of identical sub boards, sort of processor modules of some sort. A few power supply bits, so let's get this board out and take a closer look. Everything just sits on this internal chassis plate with the hinges. Now this doesn't seem to have any tamper sensing to detect it being taken off the wall, but it does have so these opto switches on the illuminator board, which these sort of tabs go into, so it can detect the unit being opened. Obviously, the front panel is the only way of getting inside it, so that if you've got a unit that's powered up, it can detect the fact you've taken the cover off. These two camera modules and two identical units here, which I looked up the part number. These are actually gumsticks, sort of computer on board modules with an SD card on there. These are sort of Linux based things. Got some Ethernet magnetics here. And on the other side we've got this micro device. This is an Ethernet switch. Obviously there's an Ethernet port on each of those these modules that's then combining into a single Ethernet output. Actually there's also a Texas CC2530 which is a Zigbee RF chip and an antenna connector, but there's nothing plugged into that, so that's probably an option for like local networking of these things, but that wasn't used in this version. The Ethernet PHY, actually I think the these boards have an Ethernet PHY each, which are then going into this switch, and that switch will be connecting to the external port. By default, it looks like this is designed to be sort of powered over Ethernet. I haven't got any PoE injectors or anything, but I did notice there is actually a footprint here for a terminal block for a separate power supply, so I should be able to power it up through that. Now, I found serial ports. There's a serial port for each of those two modules. There's all the usual Linux boot up stuff. Angstrom. There's a Texas Instruments thing somewhere. I think that's on the actual bootloader. Then there's all the sort of, it looks like it's an OMAP 3630 processor. So I think that's got support for graphics and video. So that's obviously being used for the camera inputs and recognition stuff. All the usual Linux setup stuff. And a few bits of sort of diagnostic information from the imaging stuff, but nothing particularly sensible. I can't seem to make the illuminators light up. I have seen them light up before. Maybe I've damaged something at some point taking this apart, but can't really see anything particularly interesting in here. So nothing hugely interesting on the serial output. I've had a look on these cards and the sort of all the usual Linuxy stuff and the iLock sort of code and so on, but there's nothing like interesting, like sort of screen images or captured images or anything. So and I was getting a distinct smell of something burning when I was powering it up, so I think something may have fried, or it may have been, yeah, that's why it was scrapped in the first place, I don't know. So let's take a closer look. So the illuminator board, bunch of infrared LEDs, there's a whole load of Texas TL4242 constant current LED drivers, a load on the front, a few on the back, and there's 3 RGB LEDs which are used for status indication, and there's these little opto interrupters for the fake cover tamper detection. And it looks like there's a power supply, which is a simple regulator to provide the supply for those. Now this one also does have a speaker. I don't know whether it does speech or whether that's just for beeps. I've not heard it say anything, but this thing doesn't seem to be in a hugely working condition. It does boot, but there are quite a lot of error messages appearing on the serial port, and so I did have a slight burning smell when I was powering it up. So these little gumsticks modules, these are you know, small Linux embedded platforms. They use the same stacked chip arrangement that the early Raspberry Pis used, with a RAM chip sat on top of the processor, and the power management chip, SD socket. There's an unpopulated chip which I think is for NAND flash, another unpopulated chip there which is for an option for something or other, and the camera interface. So the camera module, sort of pretty much what you'd expect these days, a digital output image sensor. These will be either buffers or level shifters. And there, can't quite get the part number on there, so I don't know. On the lens assembly, there's this. Now this, as far as I can tell, is just like an optical attenuator. It's like a fairly heavily silvered mirror. This front acrylic will provide most of the infrared filtering, so it's only seeing infrared. But this is probably just to reduce the camera sensitivity, so it's less likely to be blinded by ambient light that contains a lot of infrared. Because obviously you've got a ton of infrared coming up here, so this is a person in front of this is going to be the brightest object. So this is probably just being used to reduce the overall sensitivity to avoid overloading the camera with light. So I thought I'd take a quick look at this package on package. Processor and RAM. So this is the RAM with its pads around the edge. And this is the processor with sort of the pads on the top for the RAM, and then all the pads on the bottom for the main PCB. So as you can see, this saves a huge amount of space. You know, it's like halving the footprints, and then also saving a lot of PCB routing that might need sort of additional layers to actually get it to get it there. So it's quite a neat technique. And this is what the packages look on X-ray. On the RAM you can see sort of the trace patterns quite clearly. You can see the bond wires top and bottom. It's interesting they're running the traces right down to the edge. I wonder if that's perhaps for testing, so maybe they make it as a larger board, test it with using probes on those outer bits, and then cut it down. Or it might also be to do with plating, perhaps, I don't know. On the processor you can't see as much. I think it's probably got some sort of solid copper plane layers in there for the power planes, but you can still see quite a lot of detail and some very, very fine tracks in there. So quite interesting look at two sort of things designed to do exactly the same thing, but from probably slightly different vintages. The date stamps I found on that newer unit were about 2012 on the SD card, but the part date codes and the part date codes were similar, so there's probably about 10 years between them. So the Panasonic using its sort of analog cameras, FPGA to do the processing, and a relatively sort of slow ARM processor to do everything else, whereas the newer unit, using sort of basically off-the-shelf processor modules. I don't know whether the camera modules were off-the-shelf or custom made for this. These are sort of slightly obsolete. I couldn't find these exact modules and cameras on the Gumsticks website, but they're sort of clearly slightly more recent. But sort of these are a lot more standard. They're using Linux. I don't know whether they're using Linux on the Panasonic or not. I couldn't really get any serial data out of that, but quite interesting bits of tech. A little bit curious why they use so many constant current drivers on this illuminator board, and why they've got diodes across all the LEDs. Can't quite see why they needed that.
Please look into the mirror. Please look into the mirror. Please move back a little. Please move back a little. Please look into the mirror. Please move back a little. Please look into the mirror. Please move back a little. 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 Please look into the mirror. Please look into the mirror. Please move a little closer. Please look into the mirror.